welcome to Quartiles and Box Plots. Just before we start, a reminder that there is a notes jotter available for this video. If you just check the description below, you'll find a download link, you can get the worksheet and you can work along with me as we go through the video. Okay, so the first thing we're being asked to do is to find the upper and lower quartiles of the following sets of data, then calculate the interquartile range. Now, before we get into doing this, we need to start thinking about what they actually mean. You will have met the median before. The median is the value which is halfway through a data set. And the quartiles go along with this. So the median is half the way through. The quartiles are a quarter of the way through. So the lower quartile is 1/4 of the way through the data. The upper quartile is 3/4 of the way through the data. Now, I'm going to show you a couple of methods here for finding those quartiles, and I'm going to begin with the method that would be best used in terms of if you want to be really accurate, and that is to actually use a little bit of algebra. The position of the lower quartile is n+1/4 piece of data. Now, in this case, we need to know what n is. N is the number of pieces of data in our list. So in this case, if I have a look at how many pieces of data I have, I've got 7. So I've got 7 pieces of data. If I add 1 and then divide by 4, that gives me an answer of 2. So what that means is I'm looking for the second piece of data, and that will be my lower quartile. And so I can just count through. Before I do this, I should just point out these numbers are in numerical order. Just like with the median, you do need to put the numbers in order first. Now, 4 is the first number, so 8 will be our second number, meaning that would be our lower quartile, often shortened to LQ. If we wanted to find the upper quartile, well, because we want 3/4 of the data, we can do 3 brackets, 7+1/4. And so that would be 3 times 2, which would mean the 6th piece of data. And so again, if we count through 1, 2, 3, 4, 5, 6, there it is. Our upper quartile would be 12. Now, that is just one method. There is a slightly easier version, and if you struggle with putting numbers into expressions, or you don't think you're going to remember those two formulas, well, there's a slightly quicker way of getting there, and that is actually just using the same idea as you would for the finding the median. So if you were finding the median, the first thing you would do is count from the outside and find the middle. So smallest, biggest, smallest, biggest, smallest, biggest would leave you with 9 as your median. Now, if I want to find the quartiles, I can now just look at the numbers left either side of that value and do exactly the same thing. I can count off the smallest with the biggest on that side, and it will leave me with the middle. The middle of that set of data is going to be the lower quartile. Do the same at the top end. Smallest and biggest leaves us with a number in the middle. That will be our upper quartile. If we keep doing the same thing, using different sets of data, let's see what the methods produce. So again, the position of the lower quartile is n+1/4. Well, if I add up how many pieces of data I've got, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this time that will mean 9+1/4, which is 2.5. Now that means we're looking for the 2.5 piece of data, which means it would have to be in between our second value and our third. Now, fortunately this time, those two values are exactly the same. So our lower quartile would still be the number 8, because that is halfway between 8 and 8. If I do the same for the upper quartile, 3 brackets 9 plus 1 over 4, coming from our formula over here, then that would be 9 plus 1 is 10, over 4 is 2.5, times 3 is 7.5. And so again, it's between two values, 1, 2, 3, 4, 5, 6, 7. So it's halfway between 12 and 13. So in this case, we have to go halfway in between those two numbers, which will be 12.5. And I should just point out one more piece of information. We did this earlier, but we didn't look at the interquartile range, which was the second part of the question. And the interquartile range, much like the range is the difference between the largest and smallest values, while the interquartile range is the difference between the quartiles. And so we take our upper quartile of 12, we take away our lower quartile of 8, and we get an answer of 4. Now this is what we know as the IQR, the interquartile range. And what this means is it's where the middle 50% of people or data lies. And that's a very important factor, because they are what would be classed as the most normal people, the people right in the centre of our set of data. If we do this for our second set of data, well, the interquartile range this time would be 12.5, take away 8, which is 4.5. Now, another benefit of the interquartile range is because we are no longer dealing with the absolute biggest and absolute smallest values within the data. If we have any inconsistencies, any really big values or really small values, it doesn't actually affect the consistency shown by the interquartile range, because they'll ignore those last values on either side. So finally, we've got a set of data, and this one is the worst case scenario really for trying to find quartiles, because there are a multiple of 4 pieces of data, in this case 8 pieces of data. And that means that every single value that we find is actually going to be in between different values because of this +1. We've added 1 to the number of pieces of data, so no matter what, we're going to end up with a decimal. And so this is where I prefer the actual method of just counting in from the middle. So counting in from the outside, smallest and biggest, smallest and biggest, smallest, biggest, leaves me with 10 and 11. And so my median is going to be right in the middle of those two values at 10.5. Now, if I want to find the upper quartile and the lower quartile, I just need to now think of this set of data split in 2. And so I'm now going to use all of the values which are on the left hand side and all of the values which are on the right hand side, and do exactly the same again. Smallest and biggest leaves me with 7 and 8. So my lower quartile will come out between 7 and 8 at 7.5. And my upper quartile is going to come out in between 12 and 13. So that would be 12.5. And so in this question we have an interquartile range of 12.5 take away 7.5 equals 5. Okay, so now what we're going to do is we're going to take the values that we've just calculated in the previous question and we're going to convert them into a box plot. A box plot is just another type of diagram which allows us to display data to represent the information as clearly as possible. And you'll notice here that I've made a little box just with some key information. We've got the minimum value of the first question was 4, the lower quartile was 8, the median was 9, the upper quartile was 12, and the maximum value, the biggest, was 14. Now, the reason I've only got those 5 pieces of data is because the 5 values are the only 5 that I'm required to draw a box plot. So I'm going to begin here in the centre with the lower quartile, the median and the upper quartile. And what I'm going to do is I'm going to draw a line for each one. So the lower quartile was 8, so I'll draw a line at 8. The median was 9, so a line at 9, and the upper quartile was 12. Now, those 3 values are the key values for a box plot, and so we join them together, and what we create is a box. And that is where the name comes from, because we have a box for the interquartile range of the data. The minimum and maximum values, well, they need adding into the diagram as well. The minimum was 4, and so we draw a line for 4, and the maximum was 14, so we draw a line at 14. Now, the other thing we need to do is just join the minimum to the box, and the maximum to the box. And what that is doing is it's creating the full box plot. Now occasionally these are known as box and whisker plots, and you'll see why. We have a box and we have some whiskers coming off either side. Now I just want to add a little bit more detail to this because it's quite important what we're actually being told here. The different sections of the box plot are very important. We have basically 4 different areas. We have from the smallest value to the lower quartile. There is 25% of all of my data. Then from my lower quartile to my median, well, that's another 25%. From my median to my upper quartile is another 25%. And then finally, from the upper quartile to the maximum value is another 25% of the data. And the reason that's important is you can see that each of those sections have different sizes. They have the same number of values within them, the same quantity of data, the same proportion of the data, but they can be spread out in different ways. And so you'll notice that the first section is actually much, much bigger in terms of spread than the second section. And that just means that there must have been quite a lot of difference or quite a lot of spread within the lower portion of the data. Now we're going to do exactly the same for the other 2 questions, and all we're going to do is take the values that we have collected from the previous question and we're going to mark them onto the diagrams, and in each case starting with these 3 values in the middle, so the lower quartile at 8, the median at 11, the upper quartile at 12.5. Now in this case it's going to be slightly in the middle of the square. Create our box, and then we need to plot our minimum at 6, our maximum at 14, and join to make our whiskers. For our third question, this is the one where all of our values ended up slightly in between numbers, so we're going to end up with quite a few 0.5s in this case, but again, begin here with the central 3 values. The lower quartile was 7.5, the median was 10.5, and the upper quartile was 12.5. Join them together to make our box. And then our minimum was 3, our maximum was 16. Draw the whiskers. Okay, so our last example. This is basically the real crux of box plots. It's being able to compare different sets of data and to be able to compare them directly by having 2 diagrams very close to each other. So we start off with a sprinter recording their times for the 100 metres, and the box plot shows their results. Now, one of the things you clearly will need to have a look at here is what all of the key values are. So we know we have a minimum of 11, we have a lower quartile of 14, we have a median of 15.5, an upper quartile of 16, and a maximum of 17. Those are going to be very important values, but also the other key value here is we're going to want to think about the interquartile range. We wouldn't have a box plot if we didn't want to think about interquartile range, and so we've got from 14 to 16, so we have an interquartile range of 2. So before we've done anything, I've just read off the different values from the graph to see what we're going to come to next. So we're told that after a special training regime, they record their times again. Some results are given below. Draw a box plot of their times. And so we now need to have a look at the values we've been given. And the one thing I want you to be really careful here is that this is not the same 5 pieces of data we were given before. This time we've been told the interquartile range and we've been told the range. We have to be very careful of this. It's a little trick that is sometimes played just to make sure that you are paying enough attention. So what I do want to do is just mark the 3 values which are actually part of the diagram. We know that the minimum value is 12, and so I'll mark a line in at 12 for my minimum. I know that the median is 14, so I'll draw a line in at 14. I know the upper quartile is 15. These 3 values do not form a box though, because the one thing that we're missing currently is a lower quartile. Now, how can I think to work out the lower quartile? Well, it all comes from the interquartile range and the upper quartile. If I know that the upper quartile is 15 and the interquartile range is 1.5, then I can subtract those 2 values to find out what the lower quartile must have been. 15 take away 1.5 is 13.5. And so that is the value we actually want to plot on our graph. And that is our box. So we've got the first section. We have the box, we have our first whisker, but again, we don't know what the maximum value is. And so we need to go back and think about finding the maximum. And how can we do that? Well, we know what the minimum value was. It was 12. And we know what the range is. Now the range is from the biggest to the smallest. So from the smallest value, 5.5, we'll have to add that on. Gives us 17.5. And so 17.5 will be plotted onto our graph. Join it up, and there's our box plot. That is the start. But the main reason that we have box plots and we have them set out the way that we have in this particular question is to be able to compare the sets of results. And so we need to make a comparison. Now, if we're talking about a GCSE question, there are usually 3 marks available for this, which means we need 3 comparisons. And those 3 comparisons, we should always compare an average. We should compare the spread. And because we've got the box plots, we might want to talk about maximums or minimums, or mainly we would look for context. So what it actually means in terms of the question. So the first thing we need to focus on here is the average. So what about this diagram is an average? Well, the only average that we have is the median. And it shows that in the original series of results, the sprinter took on average 15.5 seconds. If we compare that with the second diagram, in the second diagram, they took 14 seconds. Now, key here, what does that actually mean? Well, what we're dealing with is the fact that they are running a race, and so if the average time has decreased, and let's just write the word median in there just so that we can show that that's what we were talking about. the average time has decreased from 15.5 seconds to 14 seconds. Is that a good thing or is it a bad thing? Well, if I'm running a race, I want to be as quick as possible. So now that actually means that our sprinter is running faster than they were before. Next, we're talking about spread. Now, as it's a box plot, again, the whole point of a box plot is that we want to be talking about the interquartile range. It's a massive feature of the diagram, and so it's an important feature. And so what we want to be doing now is comparing our interquartile range. In the first original set of data, the interquartile range was 2. In the second piece of data, the interquartile range is only 1.5. And so again, what we can do is just add a comment there. The interquartile range has decreased from 2 seconds to 1.5 seconds. Now again, is that good or is that bad? Well, spread is all about consistency. And so, if we have a smaller interquartile range, we have a more consistent result. And so our context would now say the sprinter is now faster and more consistent. That is all the context we need to say and to describe the comparison between the results before and after the training regime. Okay, and so now we come to the exam question, and this was from the Edexcel paper in June 2017, Higher Paper 3. This is a calculator paper in case we need it later on within the question. So the box plot shows information about the distribution of the amounts of money spent by some male students on their holidays. Work out the interquartile range for the amounts of money spent by these male students. So the first thing we have to spot here is it's talking about interquartile range. Therefore, we need to be looking at the lower quartile and the upper quartile, and we need to be reading those values as well as we possibly can. So we may want to draw some lines in. If I look at that, my lower quartile appears to be 150. My upper quartile appears to be 330. And so if I subtract those two values, I've got 180. And so the interquartile range for the amount of money spent will be £180. We're then told that the table shows information about the distribution of the amounts of money spent by some female students on their holidays. And so the smallest amount was £60, the lower quartile 180, the median 300, upper quartile 350, and the largest 650. And so we're asked on the grid above to draw a box plot for the information from the table. And so, we'll just get rid of those two lines that we drew on, and we're going to draw in the values that we've got from here. So again, I'm going to begin in the central section, the lower quartile, the median and the upper quartile. In this case, it isn't one of those trick questions. They have just given us directly all the values we need. And so anywhere on here that we like, we can start drawing our picture. So 180, there's my first line, 300, there's my second line, and 350, there's my third line. Join them together, I've got my box plot. And then I need my minimum value, which was down at 60, and my largest value, which was up at 650, and again drawing our whiskers. And then finally, Chris says the box plots show that the female students spent more money than the male students. Is Chris correct? Give a reason for your answer. Now, as this is 1 mark, As long as you can justify what you're saying, then you can get the mark as long as it is a correct mathematical justification. Now, the fact that we are talking about showing that one spent more than the other. Now, what that is pointing out to me is I should be talking about averages. So do the males spend more on average, or do the females spend more on average? And so the only average we can talk about is the median. And in this case, the male median is here. And the male median, if we read that value, is at about 250. The female median, well, we know, was 300. And so if I'm going to give an answer to this, then I will be saying that Chris is correct. The females do seem to spend more money than the males. And so I'm going to use the as the median for the females is higher, this suggests on average females spend more than males. I've used a bit of context because I've talked about spending, and I've used a correct mathematical explanation. I've used the medians to discuss who is spending more.